Like, it makes me feel better. Like, and now I'm not looking at the holes in my wall.
All right, hi folks. Folks, welcome aboard. We'll get started in about 5 minutes or so. In the meantime, if anyone has questions, please let me know. And we could certainly work through any questions while we're waiting.
Okay.
All right, folks, if you just joined, we're going to get started in about 5 minutes or so. But while we're waiting, if you have a question on WebAssign, please feel free to ask.
Hey, Larry.
Yeah. Morning, Gennaro. How are you doing?
Good.
Good. We're going to get started in about 5 minutes.
5 minutes. I actually go visit the tutor at least like twice a week.
Oh, you mean the in-person tutor?
The yeah, in-person tutor we do.
Okay.
I mean,
Um,
my tutor is Josh Massetti, my tutor.
Okay. Gennaro, do you have an alternate way to get help now that the campus is closed?
I mean, like so far there's tutor.com, by the way.
Okay, good. Yeah, I wanted to mention to everyone that you have this tutor.com here on the left-hand menu. So please, of course, make use of this.
I mean, I usually just meet the tutor in on Zoom.
Yes. Another option, by the way, is, so this is tutor.com. You come to the screen and it lets you connect with a real live person. I think I sent out an email saying that Professor Bonner is available to help with tutoring over Zoom. And of course, I'm available to help also with tutoring. So if anyone wants to get together, I could set up a quick Zoom teleconference and we could do any examples anyone is having trouble with. So just contact me if you want to set up a separate tutoring session, or use tutor.com, or you can contact Professor Bonner and she's volunteered to help out also. Gennaro, have you tried the tutor.com?
I tried the tutor.com only for my English class.
Okay. How did you find it? Was it helpful?
Yeah, I just go to submit a paper for review. That's all I did.
Okay. Yeah, that's a nice service that you can send it in for review and lets you kind of clean it up before you actually submit it, I guess, right?
Yeah, just to make sure if you're doing it right.
Exactly. But give it a try for MATH026 as well. You know, in the past, previous students that have used it for MATH026 said the tutoring was excellent. And one thing they told me was the tutors don't just like come out and give you the answer. They help you to find the answer yourself. So they kind of point you in the right direction of, you know, how to work through the analysis on your own. And that's what you want from a tutor. You don't want a tutor just show you the answer. You want to understand how to do the problem. So yeah, give that tutor.com a try if you need any help. All right, folks, why don't we go ahead and get started then? First thing I want to just mention is, as usual, I am going to record the call today. So by joining the class, you consent to being recorded. And so let me go to the calendar. Here is the calendar. So our goal today was try to finish up section 9.5. And what we're going to do today is some of the more complicated problems in section 9.5. Remember, we're trying to solve trig equations. And so when we solve trig equations, our answers are going to be angles. So keep in mind your answer here will be an angle. And usually there's more than one answer for a given problem. All right, so due this Sunday is the homework for section 9.5. On Monday, we're going to go through a practice test on chapter 9. And let me show you that practice test is posted in Canvas. So if you want to start looking ahead of that, if you come down here, here's the practice test.
That's the study guide.
Study guide, exactly right. So it's a good idea to work through these problems, and the answers are given to you in the back. And this is what we'll review on Monday. And that's going to help you prepare for the actual test, which is April 5th. You'll take that test in WebAssign as usual.
We
Okay.
also, for the final exam, it says we take it in class. We take the final exam.
Well, normally that was the plan, Gennaro, but because the campus is closed, I'm going to come up with an alternate plan. So it's likely you're going to take a final exam from home. And I haven't yet worked out the details, if it's going to be an exam in WebAssign, or you'll do a paper and pencil test and then somehow like scan your answers and email them back. I'm going to try to figure that out soon.
Okay.
But the final exam is not going to be a in-person final exam anymore because of course, the campus is closed.
Okay.
Folks, I wanted to mention one other thing about WebAssign. So you might have seen my email that I've opened up all of these homeworks until May 1st. If you can see here, these due dates for chapter 9 and chapter 10 have all been pushed out to May 1st. The intent there is to just give you flexibility so that, you know, if you have any challenges with the situation we're in due to coronavirus, you can keep working in the homeworks even past the due date. But please don't postpone these homeworks and leave them, you know, until early May. That would not be a good idea. So please try to stay on schedule per this calendar. But know that if you run out of time, you have flexibility to go back and keep working on any of these homeworks to improve your score. All right, the last thing I just want to mention is when you come here to Zoom and go up to cloud recordings, all of the recordings of our class, our online classes are available. So I'm going to click here up here on cloud recordings. And these are all the recordings from our online classes. I'm also posting here in under modules recordings with the captioning on. So you can watch these recordings if you need any help. All right, folks, let's jump back into section 9.5. Does anyone have any questions so far on section 9.5? Quick reminder, in section 9.5, what we're doing is trying to solve trig equations that are either linear or quadratic. Remember, you'll know a quadratic equation when you see one because it'll be sine squared or cosine squared. When you see that exponent 2, that's telling you quadratic. All right, so this was our game plan. It said, first step, determine whether the equation is linear or quadratic so you can solve the equation in the correct way. If there's only one trig function, you can really get that trig function by itself on one side of the equation. You know, this is like solving an equation like, you know, 2x, like, you know, 2x plus 4 equals 14. Well, you would just get x by itself on one side of the equation. And that's the same way you would handle a linear trig equation. You would get the trig equation by itself. You know, we did an example, let's say 4 sine theta was equal to 2. Well, I'd want to get the sine theta by itself, so I would divide both sides by 4. That would give me sine theta is 2 over 4, but 2 over 4 is the same as 1/2. So this would be sine theta equal 1/2. Then you go to the unit circle and locate where the sine is equal to 1/2. So I would come here to the unit circle and ask myself, where is the sine equal to 1/2? Of course, I know the sine is equal to the y value. So here the y value is 1/2. Here also the y value is 1/2. So for this equation, the answer would be theta equals 30 degrees and also theta equals 150. Okay, so we solved a bunch of these kinds of linear equations last class. But now I want to go on and look at some of the more complicated equations that might be quadratic. So let me jump here to slide 10. And this was a reminder. One way to solve quadratic equations. What you could do is factor the equation and then set each parenthesis separately equal to 0. Let me do a very simple example just to remind you of this method. I'm sure you remember this from algebra. Let's say you were trying to solve an equation like x squared plus 8x plus 15 equals 0. What you would actually, let me write a little differently just to emphasize that we have to get the equation set equal to 0. Let me change this a little bit here. I'm going to make this equal -15. Okay, so I want to solve this quadratic equation. First, I want to get the equation set equal to 0. So I'm just going to add 15 to both sides of this equation. Now I have the equation set equal to 0. Just added 15 to both sides. Then you remember this next step is to try to factor this left side. Factor means rewrite as a multiplication. So I try to set up two parentheses that are going to be multiplying equal to 0. Well, the way to factor is you put an x and an x in front. And then you look for two numbers that have to multiply to 15, but add to 8. And of course, this example is straightforward. The two numbers here would be 3 and 5. Right? Because 3 times 5 is 15, but 3 plus 5 is 8. Then you could set each parenthesis separately equal to 0. So you set it up to be x plus 3 equals 0. And you set it up to be x plus 5 equals 0. Now, these are two simple equations.
Wait, -3, -5.
Yep, x equals -3, -5. So we're going to be doing this, but instead of having an x, we're going to have a sine theta or a cosine theta. All right, so why don't we go ahead and look at some WebAssign examples. All right, let me come here to this example. And it says find all solutions on the interval 0, 2 pi. So most examples are going to say this. Remember, that means your answers can only be in this interval, not outside the interval. Of course, this is the same as saying your answer has to be between 0 degrees and 360. And you remember when they put the parenthesis on 360, it means not including 360 itself. So your answer could be 359 degrees, but your answer can't be 360 degrees. All right, well, I'm noticing here, this equation they're giving me is a mix of two trig functions. I'm seeing secant and sine. Well, let me jump back to our guidance, our method here. Here it was. It said down here, if more than one trig function is present, first get the equation equal to 0 and then try to factor the one side of the equation. So let's use this step because we do have more than one trig function in our example. All right, So it said, first, get the equation set equal to 0. Well, it's our lucky day. The equation's already set equal to 0. Then it says, try to factor the left side. Is there any factoring that you see that could be possible here? Anyone see a way to factor this left-hand side? Well, I'm noticing that in the first term is a sine x, and the second term there's another sine x. Well, what that suggests is, why don't we try to factor a sine x out in front? So I'm going to pull a sine x out in front of the parentheses. This is kind of like factoring out a greatest common factor like you did in algebra. When I do that, what am I left with inside the parentheses? If I pull a sine x out in front, notice that's going to leave me a secant x subtract 2 inside the parenthesis. All right, well, now think of it as, one quantity times another quantity equals 0. But that says I'm allowed to set each one of these parts being multiplied separately equal to 0. So one equation is going to be sine x equals 0. The other equation is going to be secant x minus 2 equals 0. And now I'm going to try to solve each one of these equations separately. All right, let me go on the left-hand side. Sine x equals 0. Well, for that, I'm going to go around the unit circle and look what angle has its y value equal to 0. Remember, the sine is the y value in the ordered pair on the unit circle. Well, when I go around the unit circle, I'm seeing here is a y value of 0. So that tells me an answer of 0 degrees is going to be one solution. I'm looking over here at 180, and that y value is also a 0. So that tells me 180 degrees is also a valid answer. I'm also noticing, by the way, that 360 degrees has a y value of 0. Should I list down 360 as an answer? No, because the interval, the allowed interval, doesn't include 360 degrees. So I'm not going to use 360 degrees. That's outside the allowed interval for this problem. All right, so that's 2 answers, but I still have to come over here and deal with the secant x part. Well, I'm going to add 2 to both sides of this equation. That gets me secant x equals 2. All right, but I really don't like working with secant because I don't have secant available to me on the unit circle. I only have sines and cosines on the unit circle. So let me do a little substitution here. You probably remember that secant is equal to 1 over cosine. So I'm going to replace secant x with 1 over cosine. So it's going to be 1 over cosine x equals 2. And let me try to solve this equation. Well, if I'm solving this equation, I don't like fractions. So let me try to get rid of fractions here. So what I'm going to do is cross multiply. So I'm going to take the fraction, take the number 2 and write it as 2 over 1. Anytime you have one fraction equal to another, you're allowed to cross multiply. So let me do that. This is going to get me 2 cosine x equals 1. Let me write it up here. 2 cosine x equals 1. Of course, I want to get cosine x by itself on one side. So I'm going to divide both sides by 2. So I end up now with cosine x equals 1/2. All right, all that's left is for me to go to the unit circle and look for where the x value on the unit circle is 1/2. Remember, cosine is the x value. Well, I'm seeing it here at 60 degrees. So it looks like the answers for this are going to be 60 degrees. That's one answer. Is there another angle where the x value is equal to 1/2? Well, if I come way down here, notice this x value is also equal to 1/2. So that angle is 300 degrees. Remember, you could write your answers in degrees or radians. That's up to you. But notice in this problem, we had 4 answers. So let me write these answers up on top just to put it all together. So we had x equals 0 degrees, 180 degrees, 60 degrees, 300. So there were 4 answers to this problem. Any questions on this example? So you had to remember factoring. And then once you have an equation in factored form, you're allowed to take each part that's being multiplied and separately set it equal to 0. And then you could solve for the angles. By the way, if you wanted to check your answer, you could take each one of these angles, plug them back in the starting equation, and convince yourself you get a true equation. That's checking your answer just like you might do in algebra. All right, let's do another WebAssign example. Okay. Here's one that involves sine and tangent. All right, well, again, you know, this is similar to the previous example because I'm noticing there's 2 trig functions. There's a sine and there's a tangent. So the directions were try to factor. Anyone see a factoring method? Well, I'm seeing a tan in common here. So let me factor out a tan in front. So I'm going to pull out a tan x. And if I do that, what's going to be left is 1 minus 2 sine x equals 0. All right, but now I'm going to set each one of these 2 quantities that are being multiplied, I'm going to set these separately equal to 0. All right, so I have tan x equals 0 here. And over here, I have 1 minus 2 sine x equals 0. All right, now let's try to solve each one of these equations separately. All right, how about tan x equals 0?
It says negative x, it says.
Gennaro, are you looking at your example in WebAssign?
No, I'm looking at yours.
Where do you see negative x? Did I have it?
It says your tangent, when you go to the x, it makes like a negative.
Here?
Right
Down
over
here?
here.
Oh, I see. Gennaro, that was my sloppy handwriting.
Oh.
Let me fix it. I'm sorry about that. I meant to write here tan positive x. Sorry about that.
Fine.
So this should just be tan positive x. All right. Let me try to solve this equation for tan x equals 0. Well, again, it's a little challenging because the tangent is not on the unit circle. Only sine and cosine are on the unit circle. But I'm remembering that when I calculate tangent, it's sine over cosine. But I know the tan x here is 0. So really, this is kind of like saying 0 has to equal sine x over cosine x. Well, the only way this fraction can equal 0 is if the numerator is equal to 0. Remember, the denominator can't be 0 because I'm not allowed to divide by 0. So the only way this equation can be true is if sine x equals 0. Because if the sine is 0, think about it. If this sine turns out to be a 0, it's going to be 0 over cosine x, but 0 divided by anything is 0. All right, so where is sine x equal to 0? We actually did this on the last slide. Here, the y value is 0, and here the y value is 0. So the two angles are 0 degrees and 180 degrees. So for this, the answers are going to be, I'll write it up here. The answers for this part are 0 degrees and 180. Of course, you could write the angles in radians if you want. All right, now let's try to tackle the second equation. I'll write it over here. 1 minus 2 sine x equals 0. All right, I just want to get the sine by itself on one side. So to do that, how about if I start off adding 2 sine x to both sides? I could also subtract 1 from both sides, but this is a little easier just to quickly get sine x by itself. So that's going to cancel out. So I have 1 equals 2 sine x. Of course, I'll divide both sides by 2. So it looks like I'm going to end up with sine x equals 1/2. Okay, now back to the unit circle. I need an angle where the y value is 1/2. Well, I'm seeing here the y value is 1/2 at 30 degrees. So that's going to be one solution, 30 degrees. Where else is the y value equal to 1/2? You might notice over here at 150 degrees. So another answer is 150. Again, we have 4 answers as the solutions on this one. So this example was kind of similar to the previous one where you had to factor out a trig function that was in common between, the first expression and the second expression. Everyone okay with these 2 examples? These are examples of factoring out a common factor. All right, let's go to the next example. All right, this one is especially tricky. And we're going to try to do factoring on this. But the factoring is going to be a little complicated. I'm going to try to follow this hint for a little guidance here. You might remember, by the way, from algebra, there was a factoring method. It was called factor by grouping. So that's another way to do factoring. So let's follow this guidance, the hints here. All right, it says, try to factor, but only look at the first 2 parts of this equation. Okay, notice it says, look only at the first 2 terms. Well, if I look just at the first 2 terms, I'm noticing that there's a sine x in common. So I'm going to factor out sine x here. All right, so let me do it. It's going to be sine x coming out. And then that's going to leave me 2 cosine x plus 1. But I'm still going to write this back part as well. And that's going to be 2 cosine x plus 1 again. All right, I'm going to put this in parentheses just to make it clear what we're going to do next. Now it says, look for a common factor that might exist. So when I look at the front and the back of this expression, I'm noticing that this 2 cosine x plus 1 is in common. So what if I factor out this parenthesis as a common factor? Let me do that. I'm going to take out in front 2 cosine x plus 1. But if I factor that parenthesis out, what I'm going to be left with is a sine x here. And if I take this parenthesis out in front, really it's going to leave 1 as a placeholder. Let me say this again, because this factoring was a bit tricky. I started out only looking at the first two expressions, and I noticed the sign x was in common. So I pulled out a sign x like this. Then I looked at what was left, and I noticed the parentheses here. I'll circle it in purple so you can see it. This parenthesis and this parenthesis is in common, so I factored that out in front. All right, well, now I have one parenthesis multiplying another parenthesis equals 0. This allows me to break this up into two separate equations. So it's going to be 2 cosine x plus 1 equals 0 for that first parenthesis. And then it's going to be sine x plus 1 equals 0 for the second parenthesis. All right, so now let me solve each one of these equations separately. On the left side here, I'm going to subtract 1 from both sides. That's going to be 2 cosine x equals -1. Divide both sides by 2. So I have cosine x equals -1/2. All right, let's solve that one. I'll write it up here. Cosine x equals -1/2. Now I'm going to go to the unit circle. The cosine is the x value. I'm looking, where is the x value equal to -1/2? Well, it looks like here's one answer. I'll write it up here. X is 120 degrees. Anywhere else, I'm looking for the x value to be -1/2.
-1/2, 240 right there.
Yep, come all the way down here in the lower left corner. Here's an x value -1/2. So here's another angle, 240. Okay. Well, to finish this up, let me go to the other equation. That was sine x plus 1 equals 0. I'm going to subtract 1 from both sides. And that's going to leave me with sine x equal -1. Okay, so we have sine x equal -1. Let me go to the unit circle. I'm looking for a y value that's -1.
270 degrees.
Yep. Turns out there's only one angle that has the y value equal to -1, 270. So this answer is 270. So notice for this problem, there were only 3 answers, not 4. Right, so again, you can't really predict ahead of time how many answers you'll have here, because it all depends on the particular value of the problem. All right, any questions on this one, folks? So this one, the factoring was a little challenging. All right, let's do a couple of examples that involve the square root property. And so for this one, you might remember that if you have x squared equals a number, you just take the square root of both sides. But you have to remember when you do that, you must put a plus or minus in front of the square root. Let me do an example like x squared equals 100. If I were to take the square root of both sides, I just have to remember to put a plus or minus. And so that would get me x equals plus or minus 10. And remember, that really means there's 2 answers to this problem. One answer is x equal positive 10. The other answer is x equal -10. If you forget that plus or minus in front, you're going to probably miss out on an answer. All right, so we're going to use this. Let me go to slide 16. All right, let's take a look at this one. It said cosecant squared x minus 4 equals 0. Well, I'm noticing this is just like an x squared equation. So I can use the square root property on this. First, by the way, notice there's just a cosecant squared, and there's not a cosecant to the 1. So this is like having an equation that only has an x squared in it. So let me add 4 to both sides to get started on this. So I'm going to add 4 to both sides. So that's going to give me cosecant squared equals 4. But I don't want to work with cosecant because cosecant is not on the unit circle. Instead, I want to work with either sines or cosines. So let me go back to this identity. You remember it says cosecant is 1 over sine. Well, if cosecant is 1 over sine, I could square both sides, and that would tell me cosecant squared is 1 over sine squared. So instead of this cosecant squared, I'm going to drop in 1 over sine squared. And that's equal to 4. Well, as usual, I'd like to get rid of fractions. I'm going to write 4 as 4 over 1. Because I have one fraction equal to another fraction, I'm allowed to cross multiply. So let me do this cross multiplying. So this is going to be 4 sine squared. And when I multiply on the other diagonal, I get a 1.
Then you have to divide by 4 then.
Divide both sides by 4, exactly.
And
So that's going to give me
1 over 4.
sine squared x equals 1 over 4. You got it? Now I can use that square root property. The square root property says I'm allowed to take the square root of both sides, but have to remember to put a plus or minus in front of the square root. So that's going to give me sine x equal plus or minus the square root of 1/4. But what is the square root of 1/4? 1/2.
1 over 2.
All right, let me break this up into 2 pieces. Really, this means sine x can equal 1/2, or sine x can equal negative 1/2. And let me solve each one of these equations separately. All right, let's go to this top one, sine x equals 1/2. That means I'm looking for a y value equal to 1/2. Well, I'm seeing that one answer is 30 degrees. And I'm also seeing over here, the y value is 1/2. So another answer is 150 degrees. All right, let me go to the other equation. That was sine x equal negative 1/2. All right, well, negative 1/2 and the y value is down here. So it looks like one angle is 210 degrees. And there's one more answer. Here's another y value that has negative 1/2. So this answer looks like 330 degrees. Oops, I'm using theta, but I should be using x here. Sorry about that. This should be x. So notice we have 4 answers for this question. All right, folks, so this ended up being a square root property because we ended up with this equation, sine squared x equals 1/4. And then we could just take the square root of both sides. You know, this is just like if you had the equation x squared equals 100, you would take the square root of both sides for that. All right, folks, let's look at a couple more examples. We're almost done. I think we just have 2 more examples to look at to cover kind of the span of the WebAssign questions.
We're almost on week 11.
Yep. All right, folks, let me look at this one. This one's a little challenging, again, because of the factoring. And by the way, folks, if you're a little rusty on this factoring or solving quadratic equations, I'll just remind you that you could go back to the Monday recording. I'm sorry, the Monday recording from March 23rd. That class was reviewing quadratic equations. So if you're a little rusty on factoring or solving quadratic equations, please go back and look at that Monday class. All right, well, I'm noticing in this example, I have a cosine squared, and I also have a cosine. Well, remember, when you're solving, by the way, of course, this is a quadratic equation because there's a cosine squared present. Whenever you have exponent 2, it's quadratic. Well, whenever you're solving a quadratic equation, the first step is to get the equation set equal to 0. So I'm going to add 1 to both sides of this equation. So let's do that. It's going to be 2 cosine squared t plus 3 cosine t plus 1 equals 0. All right, so I just wanted to get the equation set equal to 0. Now, the next step says try to factor the left side. All right, now this factoring is a little involved. Now, maybe to make this a little easier to factor, instead of using cosine, how about if I was to replace cosine with the letter x? I'm going to replace cosine with the letter x. You don't have to do this, but I just want to do this to make it a little easier to do the factoring. If I do that, that would be 2x squared plus 3x plus 1 equals 0. So I'm just replacing cosine t with the letter x just to make the factoring a little easier. All right, let me try to factor this now. Well, I'm going to try to factor it as 2 parentheses. What should I put in front of these parentheses? Well, I need one quantity times another to get me back to 2x squared. So to do that, I'm going to put a 2x here and an x here.
It would have to be plus.
Yep. Now, the reason I did that is if you were to multiply back 2x times x, notice that would get you back to the 2x squared. All right, now I need these two numbers in blue here to multiply to get me to 1. Remember, the two numbers have to multiply to get you to this constant out here. Well, this constant is 1. I have no choice but to put a 1 and a 1 in back. Right? The only way I can get two integers to multiply to 1 is to make each number equal 1 itself. So I just switched over to x's here to make it easier to factor. Let me go back and write this original problem using the factoring answer we just got. So this factoring would look like 2 cosine t plus 1 times cosine t plus 1. And you might say, well, how did you come up with that? Well, I just went back to this factoring and replaced x with cosine t because that was the original substitution we did. Let's say you're not too sure about your factoring. Well, if you're a little unsure, you could do a FOIL multiplication on this. And if you do a FOIL multiplication, you should get back to the expression you started with. If not, you know you messed up. All right, now that I have this factoring done, I'm going to set each parenthesis separately equal to 0. Okay, so here's the first parenthesis equal to 0. And here's the second parenthesis set equal to 0. All right, let me solve each one of these equations. On the left-hand side, I'll subtract 1. That's going to be 2 cosine t equals -1. Divide both sides by 2. So it looks like cosine t equals -1/2 for this equation. All right, let me write that up here. Cosine t equals -1/2. So let me go to the unit circle for this. I'm looking where the x value is -1/2. Well, I'm seeing here the x value is -1/2. So that's 120 degrees as one answer. And I'm also noticing way down here in the lower left corner, the cosine is -1/2, so that angle is 240. Okay, now let me go to my second equation. Here I'm going to subtract 1 from both sides. So that means cosine t equals -1. All right, so cosine t is -1. Let me go to the unit circle on that. Remember, I'm looking for an x value of -1. Well, there's only one answer for that. Here's the x value, -1. So it looks like that answer is 180 degrees. I made a little boo-boo here. I wrote x equals. I should have written t because we're using the letter t for the angles. Let me get rid of that. All right, so folks, 3 answers to this one. 120 degrees, 240, and 180 degrees. Of course, you can enter these answers in radians if you want. All right, again, folks, this factoring was a little tricky. So sometimes it's a good idea to just use FOIL to double check your answers. Because if your answer is not correct, if your factoring was not correct, you can usually kind of go back and adjust your factoring to get the correct answer. All right, folks, let's do one last example. And I saved the best for last. Here's a problem that's different than all of the others. Because instead of asking you to solve an equation with sine theta, it's actually going to be sine 2 theta. And that's going to make this more complicated. All right, well, first thing is I'd like to get the sine function all by itself on one side. So as a first step, let me divide both sides by 2. So that means sine 2 theta is square root of 2 over 2. All right, I want to be able to solve this equation. Folks, let me do this. Let me get a piece of scrap paper here because I think I'm going to need more room. So bear with me. Let me just open up a blank slide here and I'll put it side by side. Okay. So let me move this over here. And where we are at this point is we have that sine 2 theta is equal to square root of 2 over 2. Now, the complicated part of this problem is instead of just having a theta inside the parentheses, it's 2 theta. Your example might be 3 theta, or your example might be 4 theta. All right, here's the hint. Let's do a substitution. Let's let x equal 2 theta. The reason I want to do this is I want to make the equation look familiar. If I let x equal 2 theta, then this equation is going to change to be sine x equals square root of 2 over 2. All right. But now one thing I got to be a little careful about is what are the allowed intervals? If I go back to this original problem, notice theta has to be in the interval 0 to 2 pi. I'm going to write this in degrees to make it a little easier to work with. So I'm going to make this 0, comma, 360 degrees. So that's theta. So theta is in the interval 0 to 360. Right? That's given in the problem. But what does that mean for x? If I say theta is in this interval, what would the corresponding interval be for x? Remember, x is 2 theta. So x is double whatever theta is. Does it make sense then I should double the interval? So I could really say for x, it's going to be in the interval from 0 to what? What do you think I should write here? X is equal to 2 theta. Theta is in the interval 0 to 360. So I'm going to double 360 and make it 720. Does that make sense? I'm going back to my definition for x. It's twice theta. So theta can be in the interval 0 to 360. X can be in the interval 0 to 720. That's important so that I don't miss out on any solutions. All right, now let me go to the next step. It says solve the equation using sine x. All right, so let me write down here some values for x where the sine is square root of 2 over 2. Now remember, my intervals here can be 0 to 720. So my answers here can be anywhere from 0 to 720 degrees. Does anyone have a first answer for x that I could use? Remember, sine x is square root of 2 over 2. So what angle has its sine equal to square root of 2 over 2? Well, remember, the sine is the y value, so let me come over here to the unit circle. Here's one answer, 45 degrees. Let me look for another answer. It looks like here is another answer of 135 degrees. Are those the only answers? There's more answers because remember, I'm allowed for x to go all the way up to 720. So if I was to take 45 degrees and rotate all the way around again and come back to 45, that's going to be another valid solution. So I'm going to work out 45 plus 360. And 45 plus 360 is 405. So that's another valid answer. And there's one more, because I could take the answer 135 degrees and take that angle and rotate all the way around again. And so I'm going to add 360 to that answer. And that's getting me 495. So there's 4 answers here for x. Are all of these answers in the interval 720? Yes, it is. Can I go around the unit circle again, another rotation? No, I can't, because if I took 405 and rotated another 360, I would be outside of the allowed interval of 720. So these are the 4 answers for x. But remember, WebAssign is looking for the answer for theta, not x. So these really aren't my final answers because I need an answer for theta. Well, let me go back to the starting equation that said x equals 2 theta. let me divide both sides by 2. If I divide both sides by 2, theta is going to be x over 2. So now I want to figure out theta. But theta is going to be x over 2. So I'm going to take each one of these answers and divide by 2. So I'm going to have 45 divided by 2, 135 divided by 2, 405 divided by 2, and 495 divided by 2. These are going to be the final answers I want for theta. Remember, x was doubling theta. That was our substitution. X should be double theta. That means theta has to be half of x. So this first answer is 22.5 degrees. You could do this in radians if you want. 135 divided by 2 is 67.5 degrees, and so on. All right, folks, so this was an especially challenging problem. And there's a little trick that said let x equal 2 theta to start with. And that allowed me to get the equation to look like sine x equals square root of 2 over 2, which is a more familiar looking equation. Any questions on this problem, folks? This one, you might spend a little bit of time trying to set it up. But here are the hints to help you get started. All right, folks, looks like we're out of time. So let me know if there's any questions. If you don't have any questions, feel free to log off. Please email me over the weekend or call me or text me. I think I've given my phone number out again, but here it is one more time. 610-217-5843. Feel free to call me or email me this weekend. I'm hibernating, so I'll be glad to help out.
For chapter 9 test, how many questions would it be? Still 15 or more?
15 questions on the chapter 9 test.
And plus there's like 17 questions on the study guide.
Yeah, so the study guide is maybe giving you a little extra practice, Gennaro.
Yeah.
But on the actual test, it'll be 15 problems only.
So each question is one attempt then?
Yeah, on the test, each question is only one attempt.
Why is it only one attempt?
Well, the idea is to check that you really understand the concept and that you really know how to work through these examples because you've carefully worked through the homeworks and the practice test. Gennaro, let me go to the slide, which is a reminder about the tests. So here it is. One attempt, 2 hours, 15 problems.
Okay, so 15 problems per, so you only take the test just once then?
Right, one attempt. So what it means is you really have to know how to solve these problems going in.
Yep.
Because you only have 2 hours, you can't learn it. You can't try to learn the material during the test. You'll run out of time.
I mean, otherwise you're just wasting time then.
Exactly, yeah. So suggestion is, Gennaro, carefully work through the practice test. You know,
Yep.
Write down each one of those problems step by step.
Mm-hmm.
You know, maybe like on a separate piece of paper. And then
Okay.
once you do that, before you take the test, the actual test, review it one more time. Go over all your notes one more time.
Just to make sure. Just
to make sure. Because, you know, if you do the problems once and done, your brain doesn't remember that.
Then it's going to forget then.
You're going to forget. So it's like, you know, the next day you'll probably forget. But if you go back a day or two later and revisit that, the more you revisit the problems, the more your brain is putting that in permanent memory.
Okay.
All right, folks, any questions?
Nope.
All right, folks, if there's no questions, I will close out. the meeting, please remember to ask for help. Either contact me or use tutor.com.
All right.
Have a good weekend and hope everyone is staying safe and doing the best possible under the situation we're in.
I put in my practice test.
Excellent. All right, folks, have a good weekend. I will close out the meeting.
All right.